I never expected this answer. Now I will have to give you 50 rupees. Okay. Exactly right. Every study is correct. It is only so because the sample they have collected is from a particular, people. Okay. So that is why the results are like this. Okay. Does not mean anything. You are only adding 5, 4, 3. You are making 5, 4, 4 maybe, or 6, 4, 3, or 5, 5, 3. That's only you are doing by performing your research. If you are not getting me, because sometimes I talk Latin. Okay. So if you are not getting me, please ask. Asking is the best thing. And let me tell you, right from my school days, my teachers were wary of me because I will not leave them till the time I will understand. I will not leave the teacher till the time I will understand. And that in class, not after the class. After the class, I will not follow after the teacher. In the class, I'll keep asking. And it so happened in the year that one teacher complained against me. Okay. That he is asking too many questions. But I don't appreciate that. I will appreciate if you ask me the question. Okay. Now, are you mum because you don't know answer? Or are you mum because the question is when there are 5, 4, and 3 type of studies, how will you generalize? The answer is there. The answer is very much there in front of you. None of see this is open book question. Meta-analysis is the answer. And what meta-analysis does? It will combine the results. It will combine the results of 5, 4, 3 studies. It will give you one. Because we are analyzing already analyzed results. Okay, so it is analysis of analysis. And another thing is, see, this is what it is important. Synthesizing the research results. That is very important. And let me tell you, dear students, that not only you, throughout India, every master's PhD student research, they are just writing volume of reviews. Their guides are asking, not you, at least 50 pages of review or 100 pages of review to be written. Next time, tell your guide, oh, sorry, I should not say this. Don't tell your guide that is not required, we will summarize it. Okay. I think this will, yeah, good. That is good. That is good. And then what I was trying to tell you, 5 studies, 4 studies, 3 studies. So it is better than meta-analysis is better than that. What is the 5, 4, 3 studies is nothing but narrative review. Okay. So it is better than that, and we do the meta-analysis. Yes. Okay. So meta-analysis and empirical work, not theoretical. We are, oh, sit down, please. This is not a. This is my class. No need to stand up. Now, if I ask what is empirical, evidence based. Okay. Empirical is evidence based. Okay. Good. Quantitative, where numericals are there, and qualitative, descriptive, just description. Okay. And study outcomes are, it is study outcomes rather than the raw data. We are not using the raw data. In this meta-analysis, we are using the outcome. Outcome means, what are the study outcome? तुम तो मेरे साथ नाश्ता किए हो. That outcome, when you analyze your data, in what way your answer was correct? Okay. What way outcome you give? Don't use synonymous words. I want in what way these outcomes are. You look, when you look to your outcomes, what is that? Yes, it is number because it is numerical earlier. But what are these numbers? My questions are simple, answers are simple. These are either mean, correlation, okay, or difference aren't these the outcomes. So our meta-analysis will use such kind of outcomes, okay, not the raw data of different studies. And meta-analysis is used with single dependent and single independent. Okay, means if the correlation between two variable x and y is kind of data it will use. It will not use multiple correlation. Okay, and there it has to be a same or similar design. Who wants to be among students? Who wants to be the co-trainer with me? So generally, you take a seat, and whenever I will ask, you can stand up. Take a seat. No problem. This is my kingdom. Okay. So nobody will say anything. So what I was telling you is the outcomes. Yeah. Okay. This is one of the outcomes. Correlation or standardized mean difference. When you go to some meta-analysis paper, they will say effect size. They will say effect size. Effect size is nothing but any kind of statistic that you are bringing out from the population, sample, and it represents and it's whatever its size. That is the effect size, correlation, mean, whatever. Okay. So in correlation, you have studied. This is the formula. Is the formula correct? ZX, ZY, oblique, and what is ZX? It's nothing. It is nothing but it's deviation from the mean. Okay, that's how you find mean of x. How everything is deviating. Okay, mean of y. How everything is deviating, and how they together deviate. What is correlation? I'm saying I'm not saying correlation. I'm saying correlation. Together it is related, either going up together or going down together. Okay, that is what the correlation means. Okay, to the next. And the other one is standardized mean difference. Okay. Okay, before they do anything with the slide, now magic. Okay, that I'm going to tell you. And magics are simple thing, but only till you don't know what is happening. Magics are very simple thing till you don't know what is happening. Okay. Where is my pen? So like this and remove this also, but still it will be there. Actually, some glue is here. So that is what is the magic. So you need to understand what is the glue. Okay. So in this correlation, how we combine the correlation? How we combine the correlation? Is everyone understanding what I'm saying? I'm telling. Ask me if you don't understand. Please ask me. I'm telling repeatedly, again and again. Okay. So when we want to combine the correlations, all we will do is we will go for weighted average of correlations. Now that time I told every study is 200. Now I'm telling every study is not 200. They are of different sample size, which is in fact like that. Okay. So what you are doing is you are going for a weighted correlation coefficient calculation. How do you correlation value and sample size? Any correlation value and sample size. Sit down and say, come on, quickly. Quickly. Huh? 120 sample size correlation. Of course, one dependent, one independent. Correlation value. 0.82, everybody right. And 120 sample size. Make like this column. 0.82 correlation and sample size 120. Only PhD student will tell me. Sample size correlation 0.67 sample. Shame on you. You can't think of more than anything other than 120. 240. 316, 360 and correlation 0.9. Calculate weighted. Everyone has got phone, no? So use your phone for calculator and calculate weighted mean correlation. Weighted mean correlation means you multiply it by your sample size, add them all, then divided by total sample size all these people have. Means see this plus this into this plus this plus this into this plus then what is the total of all these things divided by into this into this into this plus 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 this into this divided by this. 0.71. Everyone should get this or everyone go and beating. Either everyone should get what you got or you're wrong. Then you have everyone done through. No, in the answer of this question is no, sir. Only those who have not done will say no. If you say yes, you are not speaking on behalf of everyone who has not done also. So has everyone done? Answer is no, sir. Has everyone done? Okay, so there are no no's. Okay, good. So see, you know the best part of it. This is called magic. The magic is all of you have already done meta-analysis. When I was telling you 5, 4, 3, now consider this. You can even change some of the values negative or something, whatever you do. Okay, you could make it some negative or make it more realistic and then calculate. Don't do it now. Don't do it now. Otherwise, you will have to recalculate. Okay. So you make it negative also. Again, while adding, it will be minus there. Okay. And so you have already done the meta-analysis. Session is over. Unnecessarily, I was talking so much. Very beginning, I would have said weighted averages is meta-analysis. One sentence. Weighted average correlation is your meta-analysis. And it is. Not that I'm not telling right. It is. But there are some problems when you are adding. Okay. The problem is the variance too much? Is there is variance too much in the weighted average? Then we will have to see. Okay. So the main steps are find the studies with similar effect size. So you have to find same X and same Y studies. Suppose if it is adoption of some, let's say, paddy, adoption of some paddy, high yielding paddy variety, HYV paddy, and maybe education, let's say. So all studies which has got adoption of high yielding paddy variety and education will collect together. And suppose these are the 7, how many are there? 7, 6. And these are the 6 studies that you have found. And these are the results that was there in the literature. And these are the correlation values and sample size. Now, do you think correlation value sample size will not be reported in any paper or thesis or somewhere? It will be reported. So you only collected that. Okay. You have not collected the primary data, mind it. But this 0.73 718, okay, 0.718 is very close to population parameter. Why? This particular result is very close to your population parameter. Why? Okay, before I answer that question, we'll suspend that question. So these are the things. You find the studies, code the study characteristics and calculate the distribution of effect size. Distribution of effect size means correlation. What is the distribution? And then examine the moderators. Moderator variables are those variables which increases the variability in the results. Okay, so you have to find out. There are no method for that. You have to examine the studies and see why can we make segregation based on some parameter. Suppose these 6 studies are 3 from before 2000 and 3 from after 2000. And if it is significantly high variability is coming, so we can segregate on studies conducted before 2000 and studies conducted after 2000. Whatever score will come, and if they are not significantly high, then in the not the value, variability I'm saying. So then we can take it as the population parameter, post-population parameter. Okay, that's what the moderator variables are. There is some magic between these two things. I need to understand that. Okay, fine, good. So what we are doing is, this my friend is coming again here. What we are doing is, in meta-analysis, we are reducing the sampling error. Are we reducing the sampling error? Okay, let me explain it differently. Let me explain differently. Let me explain differently. Let me explain differently. Okay, don't worry, don't worry. I'm used to hill conditions also, so these things is okay. Now I will come to masters. Okay, how many? 1, 2, 3, 4, 5, 6, 7. Madam, what is the age of your father? 75. Okay, 75. Now make group of 2 and find the average age. Every first, second, third, fourth, fifth, sixth, 7, 8. 54, 53, 50, 54, 50, 1, 2, 3, 4, 5, 6, 90 and 75. Every two, first, second, third, fourth, fifth, sixth, 7, 8. You got? What are those average? 1, 1, 1. First, second, average 56. Third, okay. Now combine 1, 2, 3, 4 average. That means the average of first and second and third and fourth, combine it, and fifth and sixth and seventh and eighth. 1 to 4 combine, 5 to 8 combine. 1 to 4 combine and 5 to 8. So for 1 to 4, 55. And what about the 8? Now combine the 1 to 8, means first 4 and last 4. Combine it, average it out. Now 61.8 is your population parameter. Consider that way. Consider that way. 61.8, 61.1. Let us consider 61.1. Okay. So 61.1 is the, if we consider all these 8 fathers, great fathers of mine and all of yours, if they are one population, the population parameter is 61.1. But if you have selected the sample 1 and 2, what is sample statistics? 56. It is not 61.1. What is the sample statistics of second one? That you collected. That is the sample you collected. And what is the third sample's average? 52. 52. That is also not 61. And what is the fourth? 82.5. That is also not 61.1. Okay. Now this deviation is called sampling error, not the method of sampling, nor the way you are getting the response. This deviation from population parameter. Now that you know the population parameter is 61.1, you can see that each sample that from this population, and let us assume that it is randomly drawn, its average, as you as you add, means the average of 4 and second 4, is it closer to 61.1? What? 55 is close to 61, and 61 is 67 is also close to 61. What is it? What's wrong? I'm not saying minus or positive side, close to it. Okay. So what has happened? As you have increased the sample size from 2 to 4, it tends to become closer to population parameter. That is why is telling, take a bigger sample, take a bigger sample, take a bigger sample. You must be thinking they want to punish us. That is why they are asking us to take big samples. Big samples are taken so that your sample statistics are closer to the population. Now that understand that. Don't go by the definition of sampling error that you will see in the book or in Google or anywhere. Understand what it is. Try to understand what it is, just like me in the schools or in my student days. Don't leave your teacher unless you understand. So don't leave me unless you understand. Second thing what we are doing is we are removing the error in measurement of dependent variable, and we are doing removal of error or minimizing, not removal, we should say, that is a big word, minimizing the error in measurement of independent variable. This is where it is easy. Okay, so that is why your results is the range of, since you have restricted the range of taking only very old fathers, your result is not accurate per se. Suppose if I have to take the average age of everyone present in this room, it may come around say 55 or somewhere. Okay, but if you take the average sample of all only teachers including me, it will go up to some 25 or 80 or whatever, isn't it? So that is what is range variation is, when you are selecting the sample, and if you by purposively you have or mistakenly you have selected people who are high IQ, some people who are progressive farmers only, some people who are means who are not totally representing every range of people in the population. So that is what is range restriction is called. So it will also correct the range variation in the dependent and independent variable. These are the things that it does. And how it does, 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 how it does. The meta-analysis is combining the results. All these things are done by combining the results. Meta-analysis is technical name for that. Okay, so if we have to remove the sampling error studies, what you have done is for 1200, how much? 1260 or something. What is the total? 1260. Okay, so the result of this combined what you found is 0.7 something. Okay, okay, this result is very similar to a study conducted on 1260 samples. So now what? Who said increase the sample size? You said. So this is how you have increased the sample size. Now no more your study is on 120 or 240 or 360 or whatever, 200 or whatever. You get the point? Through meta-analysis, actually you have minimized the sampling error, because now your study is, see, I am going to very fundamental things for very good reason. Meta-analysis I can cover in 10 minutes, I can tell you. In 10 minutes, I can tell you this is meta-analysis, over. But I am going into fundamentals because I understand not only you people, even your seniors, they don't clarify their fundamentals and they go ahead. Am I right or wrong? and because of that, they commit a lot of mistakes. Okay, so I'm trying to avoid that thing and let at least these 50 people have the fundamentals clear. Okay, now what do you mean by reliability is equal to 0.8 or 0.9? Reliability of measurement. All of you report. Master students may not be knowing, PhD students may be knowing. You report measurement, reliability of measurement of a result. It is with measurement, not result. Result of what? Result of measurement, you're saying? Result of measurement is okay. So what does it mean when we say the reliability is 0.8? What does it mean? You have not said anything to me so far. You are a PhD student? Bad luck. Tell me. What is the meaning that an attitude scale reliability is 0.8? Say the attitude scale is attitude towards TNU extension students. My attitude towards TNU extension student. And its reliability is 0.8. What does it mean? 80%? Accuracy is 80%, okay? Okay, that is also one way of putting it. A very simple, again, simple answer to simple question. That means something which is 1, our instrument is measuring it as 0.8. Do you agree with this? That is what is the reliability. What is your name? Did you know this? Reliability? The definitions. Try to understand things. Mug up the definitions only for what? Exams. Okay, not for understanding. So now this says that error in measurement can be eliminated or attenuated. How? How can I make 0.8 as 1? I know for sure I have only measured 5.8. Now I want to measure it as 1 because the actual measurement is 1, not 0.8. Because my instrument measures it. What is this is the problem, you know. We used to mug up the tables. You are mugging up the calculators. Okay. 5 is 60. 5 feet is 60 inches and 8 is 68. Okay. So 68. And suppose my scale is actually 11 but written as 12. So how much his height will be measured as? How much his height will be measured as? Answer me. No. His height is 5'8". Okay. I am measuring it with a scale where 12 is written. But actually it is not 12 inches, it is only 11 inches. So how much? His height is 6 feet 1 inch. Calculate again. 66 divided by 11. Oh no, sorry, 6 feet, not 1 inch. 66, no? So it will be measured as 6 feet. Got it? Because we are measuring with a scale which is only 11 inches. 11 into 6 is how much? And his height is how much? 66 inches. Okay, but since you are measuring this 11 6 times, you will say he's a 6 feet. And girls will be happy to, I'm marrying, his wife will be happy that I'm marrying a 6 footer. But actually he's only 5 feet, 8 inch. You get the point? Because our measurement is only measuring it as a 11 inch actually, not 12 inch. That's the reliability of that scale. It's not 1. See, I'm taking physical. Did you get it or not? Assume that all of you are not assuming that. Assume that that foot scale is only 11 inch actually. wrongly marked 12. And his height is 66 inch, which is 6 feet 6 inch actually. But when I measure with this, I will measure it as 6 feet, not 5 feet 8 inch. 5 feet 6 inch. Oh, sorry. You are dividing 66. It should be 68. 68. So that means 6 feet some inches. Okay, whatever. So now how will he convert this something which is measured in 0.8 as 1? Very difficult mathematical question. Even Einstein could do it by same. You can't say. See, the thing is, suppose if you have measured his height with that scale of 11 inch, it is giving you 6 feet 2 inches or something. So now what you have to do is you have to divide it by 12 inches. Suppose you have measured something which is 24. Okay. So what is the actual score? Something, tell me everyone. Now I will give really 100 rupees for this, whoever will answer correct. Something is measured as 24. The reliability of measuring instrument is 0.8. What is the actual measure? Is what? It is not, see what you have done is 24 divided by 0.8. That is what you have done. So it is 30. So the actual score is 30. Not that 0.8 will be divided by 0.8. I am just showing it with the instrument of 0.8 reliability. The score is 24 or the score is 32 or whatever. Okay. So you divide it by 0.8, you get the real value. To do it by root because multiplication is happening, no? So we have to do it with the root of Rx and after having calculated weighted mean, you also have to calculate the variance of the correlations. Like this. This is the formula for that. And if this variance is found significant, then we will have to make subgroups, which I told based on the monitor variable. It can be year of studies. It can be studies conducted in South India, studies conducted in North India, studies conducted in Western India, studies conducted in Southern India. Studies conducted in states whose per capita income is above this and studies conducted in some states whose per capita income is below this. The moderator variables can be anything that you can think of that these might have affected. There is no method for that. There is no methodology for that. You have to individually think about difference is coming. You have to look into the studies, see its characteristics, see it whether land laborers, whether it is on safe on campus. You feel safe. When you go out, you feel the similar level of safeness or more or less out of the campus. Yes. So your confidence interval is TN. We've been talking about sample statistics and population parameter. Now this confidence interval shows that the statistics that I have calculated. Wait a minute, this is important. Come, you will miss it. No. You can go, but just listen to me what I'm saying. The sample statistics that you have calculated, we don't report one point, we report interval. And the interval is calculated this way. The correlation plus minus 1.96 under root standard deviation square divided by K. K is number of studies. Okay. So it will give you a range. Now with 95% confidence, I can say that the population parameter should lie between these two range. Is it better than saying that my population correlation will be 0.8 if my value is 0.8, or is it better to say that it will be between 0.75 and 0.85? Which is better? So don't henceforth report your sample study also as a point estimate, because point estimates are not that accurate. You are not at all 100% sure about that. If you calculate the confidence interval, which formula is there, and for other statistics also there is formula. So if you report from that this is the population parameter shall fall in between these two range in between the range this. Okay, now you can go. Okay, so this is how we calculate. Sampling error variance, the formulas are there. I'm not going to get into the formulas of those things. Okay, this can be calculated this way. And again, our sample error and sorry, what is this? What is it, sir? What is this connotation called? No, no, rho is different, sir. Not this. Sigma. Rho is this one. So sigma square, that is variance of our sample and error variance. If you minus that, then you get population variance. Okay, this is how it is calculated. And if it is significant, I will show you another formula. This is the chi-square test for that. If this is significant, then you segregate. Don't go by formulas. Okay, those things I'm going to give you very simple things. Okay, solution for that. If it is this value comes significant, that means the studies that you have combined are not from the same population. That is what it means. Define either based on year, based on gender, like politician, you divide. Okay, so that is how you find out chi-square, and you divide. If it is the what is the value range where our population parameter is for. I'm not going with example because right now I'm not going with example. I'll go with example. Do you think these are the things that we have come? And the last part, theory building. Through meta, we can build the theory. What I ask you? In the beginning, I asked you, what is the aim of science? So, if you are able to find out the population parameter through meta-analysis, which is very affecting adoption of high yielding variety of paddy or not. Okay, that kind of theory you have. Theory means not every time E is equal to MC square. Okay, in our social science, our theories are this kind of theories. And this is not based on a single, which will have a lot of sampling error, which will have lot of measurement error, are not in a position to generalize to that extent because of all kind of limitations. But a meta-analyzed result, suppose these are on 20, 30 studies, similar studies, the results that you come with, you can very well generalize, write a theory statement of that this is the theory. Okay? And the best part of everything now, magic number 2. This is magic number 1, that you can make theories. Magic number, you have to bring laptop if you want to know about this package, or you can share with student. I'm downloading you in front of you, so if you don't understand, you can download it, then run it. I'll come from washroom meeting. Let them download it, and we'll have a lunch break. After lunch break, I'll explain, and then simulation also. So, though if we are not able to download, don't bother. We'll come back then after lunch. Okay. Hopefully, you will get the lunch in your hostels, and we'll come back. So when we are coming back? No, but that immediately. What is that? 1 hour. Okay. For lunch break also, sir. I want to get one assurance. The way I am presenting is okay, or should I just stand here deliver the lecture? What do you want? It is okay. Okay, good. Because no, if you are feeling bored with this kind of arrangement, then I can switch over to another method also. Yes, this software, I'll let you know how to use it. Okay. Everyone come, or if you have not brought the laptop, please bring. And if you come beforehand, just download it, install the software, and then when I come, we'll have it.